Okay, so today, of course, we will start with 3:1. And I don't want you, okay, so it's a new chapter, right? I don't want this chapter to be just another chapter. I want to tie in what we are doing on the project into the lessons for today as well. But at least I want you to write down the title of it. Of course, today we are doing what?
3-1.
Which is?
Triangle.
Representing relations. Okay? That's what we're covering today. So, let me calibrate this a little bit here. I don't know why I have to do this every single time, but oh well. Just for fun, I guess.
Did you see it?
Stay focused. Yeah, sure. You can see that too. But, as we talk about this, I want to bring us back to our project because I think it's important enough. So let's take a look at the project, okay? Hold on. Here it is. Let's play this again. As I start this project for you, we call this here the first iteration. Is that correct?
Yes.
Okay. So that's the first. Second iterations is right here. Third iterations is coming. There you go. That's third iteration, right?
Like umbrella.
Okay. Fourth iteration. How many triangles do you see here? Fourth
1, 2,
iteration?
3, 4, 5, 6, 7, 8.
8. Okay. So notice that instead of trying to keep track of that by saying, okay, 0, first iteration, 0, second iteration, 1, third iterations, 3, fourth iterations, 8, we need to have a way to keep track of all of our data, right? And the reason why I'm covering this lesson is because we can actually do that by using ordered pairs. Ordered pairs. We start with that first, which is a point. So for instance, if we start with a point, oh, by the way, how do we represent a point? Using what? How do we put together a point?
Pair.
Which made up of?
2 numbers.
Which is, what's the first number is going to be? What's the second number is going to be?
Dependent variable.
So you tell me all those things. So let's go back to the very basic. Is that true that we have x and y?
Yeah.
X is known as,
X coordinate.
Independent variable.
you forgot this,
Domain.
domain. Isn't it? Isn't x domain? And the y is called what?
Range, guy.
The range. So I'm going to use x for domain, range, and y. Let's go ahead and bring up all the terms and associate with the domain. What's another way to call x?
Input.
What is it? Thank you. Independent variable. So we call that independent variable. That's also known as the domain. What else?
Input and output.
At the same time?
Input.
Input. Thank you. So another one for it is also known as the input. Okay, so this is associated with, these terms associate with the domain. Look at the range now. What else can we say about the range?
Dependent.
Dependent. Okay, so I'm going to go ahead and write dependent here. And what else? Output. There you go. So every time now if I mention dependent variable, you should know that I'm talking about the y, or output, or, you know, the range. Does it make sense? Okay, what is it? Okay, now that we have our definition of a point, let's put together our data point, and let's form it. First of all, if we define x to be our iteration, and y to be our blue triangles, then I can form it like this. My first iteration, how many blue triangles do I see? 0. I just form a point to keep track of my data. First iteration, 0 blue triangle. Second iteration, how many?
1.
1. Third iteration, 3. Fourth iteration,
8.
8. Okay, so that's kind of hard to see, but let me see if I can actually do this. And do this. Haha. A bit better. Okay, look. What I have right here is a set of points, right? We don't just say, oh, yeah, this is a set of points. But instead of calling this, we call it collectively as a relation. So now that we have a set of points, we call this set of points a relation. So what does it really do? A relation really is describing what's going on with our situation. We are trying to use a set of data points to describe things that happen in this triangle. In this case, we're trying to count how many blue triangles are in this big triangle. Okay? So, let me just go ahead and redefine it with you again. We use a point to keep track of our data. When we have a set of data points describing a situation, we call that set of data a what? What is this set of data point called? A relation.
Good job, Gary.
Okay? Any question on that part? What a relation is, what a data point is, what do we know about the domain, what about the range, and all those things. Okay, we'll go to that part, right? Now, why is it so important for us to keep track of data anyway?
So you won't get mixed up.
Okay, first of all, don't get mixed up. What else?
Yeah, overwhelmed.
To organize, well, that's why the mixing up part is all about. What else? Why is it so important for us to collect data?
So we can find an equation
Okay, so now you're trying an equation to do what?
Just solve your questions.
to solve how much there is.
There's more than that.
certain-
Why did we use? Okay, what do we put these points on?
A graph.
Yeah.
A graph. Why do we look at a graph anyway? Why do we have a graph in the first place?
To see
To see what?
how much it increases or decreases.
Okay, what is that overall? What is that we're looking at a graph? If you're a business person, you're looking at a graph to really decide what?
Change.
Looking for change, looking
It
for
starts with an S, right?
looking for what? Looking for what? Come on, I'm looking for the right word here.
Does it start with an S?
What's it start with?
A T,
Oh. Term.
Triangle.
Huh?
Termination. Term.
not term.
Time.
Not looking for time either.
Wait up. What's the second letter?
R.
Triangle. Yeah, triangle. There you go. Okay.
We're looking for a
Triangle.
a what?
A trick.
Not a trick.
A trend.
Huh?
Trend.
Trend.
Oh,
Thank you.
God, that was
We're
killing
looking
me.
for a trend. Why? Because when we have a trend, we have a pattern, don't we?
Yes.
Yeah.
With a pattern, we can predict.
Uh,
Is that true? And this is the whole point of our project. We're trying to see if there is a trend or not. If there is a certain pattern that we see, then we can certainly predict what will happen in, like, for example,
the
if we
729.
okay, if you're you're collecting data on the rainfall since the year 1000, whatever. Okay, if you have enough data, you can actually use that data to predict what will happen in the next 1,000 years because you have seen enough data to do the prediction. You see what I'm saying? And what we're trying to get here is that if we have enough data point, we don't need all the data points, but if we have enough to make a prediction, you can certainly answer the question, how many blue triangles are going to be in the 81st iteration without having to graph every single point? Or how many blue triangles will there be in the 729 iterations? That's what my point is here. Okay, let's learn a couple more tricks on this. Yes, we know that we use a point to plot on a coordinate plane and graph them, right? But do you also know that for our relation here, we can also do a mapping diagram on this? Okay? But before we start doing a mapping diagram, I want to show you something here and you tell me what I'm doing, okay? Watch.
Drawing a line.
Make a snowman.
Yeah, that's awesome.
What did I just do?
You flip down.
I flip them. Okay, what's the fancy word to do flipping?
Reciprocal.
There's another word for it.
What does it start with?
I.
Inverse.
Inverse, thank you. So, when I did the flipping like that, I'm trying to make it easy and to connect with you, but when I did like this, we call this an inverse what? This is called a relation, so we flip, we call this an inverse what? Relation. That's all we're doing. So I'm teaching you new terms, but it's not really that bad to remember. I have a relation, so if I flip my two x and y, I call that an inverse relation. Okay, are we clear on that part? Who doesn't get it yet? Okay, kind of. Okay, what part don't you understand? Trey, what part? No, let me know. Which part? Care to share? No? So, do you understand the part about plotting a point? I mean, coming up with our data, looking at data, and be able to convert back to a point. Notice I define x to be my iteration, y to be my blue triangles, and I just keep track of the iteration. We're good with that part? And then, if I happen to flip it, depending on what you need, if I want to have my blue triangle first, I flip it. This is called an inverse relation because I'm flipping the x and the y. Okay? Now, next part I want to teach you today is called the mapping diagram. How many of you have heard of that term before? A mapping diagram. Okay, good. Well, for those of you who have not heard of that, let me just show you what a mapping diagram looks like. Here's a mapping diagram. What does it look like? Well, first of all, to make a mapping diagram, you have to identify two things for me: the domain and the range. Where's my domain? The x. So we're going to go and circle all the x right there. Maybe I should use a different color. There it is. And where's my range? The y. So what I do now is I set up two columns as well, the domain and the range. So here's my domain, here's my range, and in the domain, I list out all the domain. What kind of domains do I have here? 1, 2, 3, 4. What about my range?
0, 1, 3, 8.
0, 1, 3, 8. Okay? And to do a mapping diagram, all you have to do is just pair up your domain and your range. In this case, I know that 1 is pairing up with a 0. It's notice it's hooking up. All right, 1 is 0, so I just also link it up. 1, 0. What else is linking?
2, 1.
2, 1. What else?
3,
3, 3. What else?
8.
4, 8. This is called a mapping diagram. So I'm taking a point, instead of just representing it using parentheses, x comma y, close parentheses, this is just another way to represent that set of data points. Okay, any question on a mapping diagram? Now here's another variation to the mapping diagram, and I need you to understand what's happening in this part, okay? So watch this. Let me clear this up for a bit. Let's say I give you this set of data points. 1, 3, 2, 7, 3, 3, 5, 7. Okay, let's say that. This is my relation. I don't know what's describing, but I'm just calling it a relation because that's my set of data points. I want to put this back into a mapping diagram. What's the first thing I'm going to do again? I forgot how.
What'd you say?
How do I put this into a mapping diagram?
Oh, you list out the domain.
Okay, so identify the domain and identify the range. And then I also create two columns. Here's my domain column, and here is my range column. Okay, is that hard so far? Okay, in the domain, what do I write?
1, 2, 3, 5.
Okay, 1, 2, 3, 5. 1, 2, 3, 5. You can actually sort them in order. That's fine if you want. I don't really mind. And then on the range side, what do you write?
3, 7, 3, 7.
Okay, 3, 7, 3, 7. Now watch this. Why did I just write 3, 7 and not 3, 7, 3, 7? Right.
Because there's 2 of them and you just
Right.
combine them.
Okay, so here's the thing that I want you to remember for the rest of your life. If you are ever doing a mapping diagram, did you see this? Ooh.
Okay.
No duplicate ever. If you see a duplicate number, do not even write it in there. You see it? Because notice I see a 3 and I see a 3 again, I don't write it again because it's already in my set.
What about your 7s?
Okay, same thing for 7. I see a 7, I write the 7, but then if I see it again, I don't write it. No duplicates, okay? So this is something that you need to remember when you do a mapping diagram. That applies to both the domain and the range, not just the range. But if you see duplicates in the domain side, you also write only one time, okay? Now let's go ahead and start linking them up. The 1, where does it go? The 3. What about the 2?
The 3.
7.
Oh, no, wait.
And the 3.
3.
Go to the 3. What else?
7.
5 to the 7. And there you go. You have yourself a mapping diagram without any duplicates. But still, you represent how many points here? 1, 2, 3, 4. 4 lines, 4 points. You see how that works? Question so far? Who doesn't get it yet on how to do a mapping diagram? Okay? So, well, I'm trying to use a different way to represent a data point. Instead of graphing, you can do a mapping diagram. And yes, for the next section, which is 3-2, you will see why a mapping diagram is also a good tool to decide whether something, a relation, is a function or is it not a function. Okay? So that will conclude my lessons right there. Any questions so far on this? All right, let's conclude this.